We based most of our design around existing literature, including this article called Haptic Revolver, Touch, Shear, Texture, and Shape Rendering on a Reconfigurable Virtual Reality Controller. The article went into depth about a revolving texture-based controller for VR. While the controller from the study was handheld, we wondered how we could make this controller more novel. Hence, we aimed to improve the user experience and haptic feedback through a wearable controller so interaction could occur with more fingers. To visualize the design of a controller, we prototyped with many materials. This was done to understand how a controller would work and how we would implement it. In our design, the controller would be attached to the arm so the users are able to feel textures with multiple fingers on the wheel when it spins. Fusion 360 was used to model and 3D print the wheel and its plug. Textural elements will be placed on the surface of this 6 cm diameter wheel. To build the base component of our wearable controller, we used a laser cutting template to create the arm section. We then connected the laser cutting materials through bolts and screws to form almost a robotic arm extension for the wearable section of the controller. The arm component plus wheel were then connected with nuts and screws. Hardware components such as Arduino, servo motor, and DC motor were used to join the controller. We then connected the controller to the laptop to test how the controller would function. Temporary straps were placed to hold the controller to the arm. To make use of our controller, we decided to go with the Shopping Experience VR demo. Users would be able to feel various cloth-based textures using our controller. This was developed with Unity and a VR headset. Our texture feedback controller would allow a user to touch a clothing item in VR and feel that same texture on the wheel simultaneously. When a user goes to reach a cloth, the wheel comes up and spins accordingly to that texture, but goes down when a user has not selected that clothing item. Our final controller looked like this. The wheel contains different clothing textures for the user to interact with. Multiple fingers could be used instead of only one finger. This experience makes the controller more interactive whilst providing haptic textural feedback. More stronger Velcro straps were added to increase the flexibility adjustment part of the controller for different arm and hand types. In the final stages, the Unity demo shopping experience with the VR as well as our wearable texture feedback controller was put to the test. Our controller worked as expected and provided many users with textural haptic feedback through the developed demo. It allowed for user experience to occur with the controller and the VR demo. The wearable texture feedback controller did meet our initial aims and could be developed further in the future.